So we're doing the ramp problem, and the question is: imagine you are designing a wheelchair ramp. You have been asked that the ramp be shaped like a sine wave that goes through exactly one full period before it reaches the top. The ramp should travel a total vertical distance of 10 meters from beginning to end. Per ADA guidelines, the ramp slope should be 112. That means that if we call the vertical component z in our vector function that travels along the curve, dz over ds should be 112, where the s is our arc length parameter. So for the first question, it's what is a straight line distance from the beginning of the ramp to the end? And so we're given our x, y, and z components here. Our x component is x of s, and then our y component is sine of pi over 60. And it's pi over 60 because it's one full period of the sine wave. And we know that's 2 pi over 120, which is why later on we'll be integrating from 0 to 120. So that's why our y component is sine of pi over 60, s. And then our z component is 1 over 12, s. And then so we take the derivative of our r of s function, which is taking the derivative of this, and we get x prime of s for our x component. For our y component, we get pi over 60 times cosine of pi over 60. And then for the z component, it's 1 over 12. And so we know that when we take the magnitude of our r of s function, that's equal to 1. So then we set our derivative of r of s equal to 1 here. And then when we set it equal to 1, we take the magnitude of our derivative here, and it simplifies down to, here's all the math. It simplifies down to this, and we get 1 equals x prime of s squared plus pi squared over 3600 cosine squared pi of 60s plus 1 over 144. And so to find the total change in the x direction, that'll give us the straight line distance. We integrate from 0 to 120, how I explained earlier, that it's one full sine period. That's why we integrate to 120. And that's the total distance of our arc length. So here's our function. We plug in this, and we integrate that from our bound 0 to 120. And we put this into the computer, and pretty much it gives us 119.5 for our distance. And now I'll pass it on to Alex for him to do question number 2.
Okay. So for question number 2, we want to find the curvature of the sine ramp, and we want to find out what the max value is and what x values it occurs at. So the curvature function is the magnitude of r double prime of s, and from the first question we determined that r single prime of s has an x component of 1 minus pi squared over 3600 cosine squared pi s over 60 minus 1 over 144, a y component of pi over 60 cosine pi s over 60, and a z component of 112. And then to get r double prime of s, we need to take the derivative of r single prime. And to do that, you need to use the product rule and the chain rule. And you get a final result of pi cubed over 216,000 cosine pi s over 60 sine of pi s over 60 all over the square root of 143 over 144 minus pi squared over 3600 cosine squared pi s over 60 plus negative pi squared sine pi s over 60 all over 3600, and then the z component, since it is a constant, when we take the derivative of that, it becomes 0. And then to take the magnitude of r double prime of s, you take the square root of the x component and the y component, you square those, and then take the square root of the whole thing. And I don't really see a nice way to find the maximum of this whole function and at what x values it occurs at. So at this point, you can plug the magnitude of R double prime of S in the Wolfram alpha, and at the very end of your input, you specify your interval, which, as we stated in question 1, was 0 to 120, and then you hit enter, and it gives you a max of pi squared over 3600, and that occurs at x equals 30 and at x equals 90. Thank you. I hope you found our video informative.